Good morning, my dear students. I am Mohammad Bahuddin, working as an assistant professor in ISL Engineering College, which is affiliated to Usman University, Hyderabad. So today in these sessions, we are going to learn the first problems on the curve beam. The problem is based on the punch press machine. Okay, the frame of a punch press as shown in a figure. Find the stresses at the inner and outer surface at the section x minus x of the frame if load is given as 5000 Newton. So this figure is given in this problem. So if we observe this figure, so this figure we can say as punch press machine. What we can say? Punch press machine. So if you observe this radius, so this radius, what we can say? We can say as inner radius. What we can say here? Inner radius. And this radius of this circle we can say as outer radius. So this one is inner radius and this one is outer radius of the punch press machine. Clear? So here the load, how much load is applied on the punch press machine is there? 5000 Newton load is applied on the punch press machine. Clear? So this is the axis, or we can say that it is the section x minus of x. So this figure, it is looking like a taper bar. So this is the inner width or inner breadth of the taper bar. It is given as 18 mm and the outer breadth of the taper bar is given as 6 mm and this height is given as 40 mm. First of all, you have to write down the given data in which you have to represent that we applied the load of 5000 Newton we applied on the punch press machine. How much load we applied? 5000 Newton is applied on the punch press machine. So this inner width of this taper bar, it is represented by BI equal to how much is given? 18 mm, and outer width of this taper bar is given as 6 mm and this height is given as 40 mm. Clear? Then if you want to measure the inner radius, first of all you need to cut this section x and x section, or we can say that x or x bar, we can say that. So from this origin point we are measuring the inner radius. The inner radius is given as 25 mm. From we want to measure the inner radius, how much we got it here? 25 mm. Our intention is there, we want to know about what is the outer radius of the punch press machines. So inner radius, from we have to measure from 0 to inner radius, how much is there? 25 plus from x to x, how much distance is given here? 40. So height is how much is given? 40. So we can say that 25 plus 40, then you will get the outer radius of the punch press machine. Clear? But in this problem what we need to find out, our intention is there, we want to find out the stresses at the inner section as well as we need to find out the stresses at the outer surface we need to find out. So first of all we need to find out this area. Okay, if you want to find out the area of the sections, so we have to use the formula area is equal to 1 by 2 base into height, but actually here two base is given. So one is inner width and another one is outer width is given. For that reason what I am doing over here, I am using the formula is 1 by 2. Inner width is how much is given? 18 mm, outer width is given as 6 mm, height is given as 40 mm. So if you divide with the help of calci, then you will get the answer is 480 mm square. Area of this cross section at x minus x, it is given as 480 mm square. After that we need to find out the radius of curvature of the neutral axis we need to find out. So first of all, you need to remember how to find out the radius of curvature of neutral axis. For that reason, first of all, you have to understand this figure, then only you can easily solve the first step of the problem. Let us see. This is, we can say, C is represent the centroidal axis and N is represent the neutral axis. So inner width is given as 6 mm and outer width is given as 18 mm and height is given as the height of the taper bar is given as 40 mm. So let us see how much load we applied over here is 5000 load we applied on the punch press machine. So this is the section X and this is the section XX. From this one we are measuring. If you want to measure from here to here, so we can say as inner radius. Okay, what we can say here, if you are measuring from this reference axis from the section X minus of X, so we can say that if you measure from here to first end, this end, okay, inner end, so we can say as inner radius. What we can say here, inner radius. If you want to measure from this section X minus X to N, one N, what we can say, neutral axis. What we can say here, neutral axis. If you measure from the section X minus of X to up to here, up to N, so we can say as radius of neutral axis. What we can say, radius of neutral axis. And if you measure from this centroidal axis from the section X minus of X, this R we can say as radius of curvature. What we can say, radius of curvature. And if you measure from section X minus of X to outer radius of the taper bar, so we can say as outer radius. So RIs indicate inner radius and RN nothing but radius of neutral axis, R nothing but radius of curvature, or we can say as centroidal axis, we can say that. And RO we can say as radius, outer radius. Clear? Then always remember this eccentricity is always lies in between the centroidal axis as well as in between the neutral axis. Clear? So for that reason, what is our main intention is there, we want to find out the radius of curvature of the neutral axis, Rn we need to find out. So for that reason, what I am doing over here, we are using the formula of radius of curvature of the neutral axis. We have the formula Rn is equal to inner width plus outer width by 2 into height by inner width into outer radius minus outer width into inner radius by height log E outer radius by inner radius minus inner width minus outer width. Clear? Then after that, so inner radius is already is given. How much is given here? Inner radius is given as, inner width is given as 18 mm. Okay, 18 mm is given and outer width is given as 6 by 2. Height is given as 40 of the taper bar. And inner width of this taper bar is given as 18 mm and the outer radius of this is given as 65. Clear? Minus outer width is given as 6 mm of the taper bar, inner radius is given as 25 by height is 40. Log E outer radius is given as 65, inner radius is given as 25 minus inner width is given as 18 and outer width is given as 6. So if you divide the whole the value, then you will get the answer is 480, as well as if you are divide this 18 into 65 minus 6 into 25 by 40, then you will get the answer is 25.5. Log E 65 by 25 if you divide, then you will get the answer is 0.9555 minus 18 minus of 6 should be how much? 12. If you divide the whole the value, then you will get the answer is 38.83 mm. So how much the radius of neutral axis, how much we got it here? 38.83 mm we got it of the radius of neutral axis. Clear? After that, what we need to find out? We need to find out the radius of curvature. So sometimes we can say as radius of curvature of the neutral axis. Is it right? So for that reason we have to use the formula is r is equal to inner radius plus height, inner width plus 2 into outer width by 3, inner width plus outer width. So inner radius is given as 25 plus height is given as 40, inner width is given as 18 plus 2 into outer width is given as 6 by 3, inner width is given as 18 plus outer width is given as 6. If you divide this whole the value, then you will get the radius of curvature of the centroidal axis is how much we got it, 41.67 mm. So after that our main intention is there, we want to find out the centroidal axis. So how to find out the centroidal axis? Because this eccentricity lies in between the centroidal axis as well as in between the neutral axis. So for that reason our intention is there, we want to find out the E. Is it right? So E equal to the distance between this R, nothing but centroidal axis, minus Rn is represent the neutral axis. So R is how much is there, 41.69, minus neutral axis is given as 38.83. So if you subtract the value 41.67 minus of 38.83, then you will get the answer is 2.84 mm. Clear? Again we need to find out the distance between the load and the centroidal axis. We need to find out. So here, from here to here, how much is there? I represent here x is equal to 100, plus we want to measure from this x-axis 100 plus this radius, okay, because we want to measure up to centroidal axis. Is it right? For that reason we are x is equal to 100 plus outer, sorry, 100 plus r. What we can say, 100 plus r. So x is nothing but 100 plus the radius of centroidal axis, 100 plus radius of centroidal axis, 100 plus. So radius of centroidal axis, just now we got it how much, 41.67. If you add this value, then you will get the answer is 141.67 mm. After the getting the value of the distance between the load and the centroidal axis, our intention is there, we want to find out the bending moment about the centroidal axis. We need to find out. If you want to find out the bending moment about the centroidal axis, we have to use the formula is load into distance. How much load we applied over here? We applied the load of 5000 load we applied on the punch press machine, and distance from here to here from the centroidal axis, how much is there? 141.67. If you multiply this value, then you will get the answer is 708350 Newton meter. Clear? So the unit of load is Newton, the unit of distance is meter. After that our main intention is there, we want to find out the tensile stress at the section x minus of x. We need to find out. For that reason what I am doing over here, we are using the formula of tensile stress is equal to load per unit area. How much load we applied? 5000 by area is how much is there? 480. If you divide the whole the value, then you will get the answer is 10.42. The unit of load is Newton, unit of area is millimeter square. So we know very well 1 Newton per mm square should be equal to 1 megapascal we can represent. Okay dear. So we got the direct tensile stress. After that our main intention is there, we want to find out the distance from the neutral axis to inner surface. We need to find out. So if you want to find out this inner surface, if you want to find out the neutral axis to the inner surface, so for that reason we have to use the formula is yi is equal to Rn minus of Ri. So Rn nothing but, let us see over here. So we are measuring the distance from here to here. So this one, what we can say, the radius of neutral axis. What we can say, the radius of neutral axis minus of inner radius, minus of inner radius. From Rn minus of Ri, we can say that. Is it right? So the radius of neutral axis is given as 38.83 minus inner radius is given as 25. So if you subtract this value, then you will get the answer is 13.83 mm. After that, our intention is there, we want to find out the distance from the neutral axis to the outer surface we want to find out. So if you want to find out this outer surface YO, then we have to use the formula here RO. So outer radius minus of radius of neutral axis. Radius of neutral axis. So we can say that RO minus RN. We can say that. Is it right? So the distance from the neutral axis to outer surface is given as outer radius minus of radius of neutral axis. So outer radius how much is given? 65 is given minus radius of neutral axis given as 38.83. So if you subtract this value, then you will get the answer is 26.17 mm. So this means that the distance from the neutral axis to the outer surface, how much we got it here? 26.17 mm. After that, our main intention is that we want to find out the maximum bending stress at the inner surface, as well as we need to find out the maximum bending stress at the outer surface we need to find out. If you want to find out, we have to use the formula is sigma bi. So B is indicate bending and sigma is indicate stress. I is indicate inner surface. Okay, so we can pronounce like that. So the maximum bending stress is acting at the inner surface equal to, we have the formula is bending moment into the neutral axis to the inner surface, by area of cross sections into eccentricity into inner radius. So M bending moment, how much we got it here? 708350 into neutral axis to the inner surface, how much we got it here? 13.83 by area of cross section, how much we got here? 480 into eccentricity is how much we got it here? 2.84 into inner radius is how much we got here? 25. So if you divide this whole the value, then you will get the answer is 287.4. The unit is Newton per mm square. The unit of stress is Newton per mm square. Because we are getting the answer is in positive, we can say that the direct tensile stress is acting at the inner surface. Which force is acting? The direct tensile force is acting at the inner surface. If you want to find out the maximum bending stress at the outer surface, then we have to use the formula is maximum bending stress at the outer surface. It is represented by sigma BO equal to bending moment into YO, nothing but the neutral axis to the outer surface by area of cross sections into eccentricity and outer radius. So always remember, no confusion over here. Instead of M as it is, instead of YI we have to represent here YO. That's it. AE as it is. R instead of RI inner radius we have to represent here outer radius equal to. So M is how much we got it here? 708350 into YO, how much we got it here? 26.17, and area is how much we got it here? 480 into eccentricity, how much is got it here? 2.84 into outer radius is how much we got it here? 65. So if you divide the whole the value, then you will get the answer is 209.2 Newton per mm square. The unit of maximum bending stress at the outer surface, how much we got it? 209.2 Newton per mm square. So that's what we can say, that it is a compressive force is acting at the outer surface. So at the inner surface, the tensile force is acting at the inner surface. But our intention is there, we want to find out the resultant stress at the inner surface, as well as we need to find out the resultant stress at the outer surface we need to find out. So the resultant stress on the inner surface, we have the formula is direct tensile stress plus initial bending stress. Okay, or we can say that inner bending stress. So direct tensile stress, how much we got here? 10.42 plus sigma bi direct bending stress at the inner surface, how much we got it here? 287.4 Newton per mm square. If you add this whole the value, then you will get the answer is 297.82 Newton per mm square. So instead of Newton per mm square, we can represent as 1 megapascal. Clear? After that, the resultant stress at the outer surface we need to find out, equal to direct tensile stress minus of direct bending stress at the outer surface. So direct tensile stress, how much we got here? 10.42 minus bending stress at the outer surface, how much we got here? 209.2. so if you subtract together, then you will get the answer is minus 198.78. so for that reason, minus is nothing but compressive force is acting on the outer surface. So and the maximum tensile stress is acting at the inner surface, as well as the maximum compressive force is acting at the outer surface. How much we got it here? The resultant stress on the outer surface, we got the answer is minus 198.78 megapascal, because instead of minus I am representing here compressive force is acting on the outer surface. I hope so no one is having the doubt regarding this problem. If you have the small doubt regarding this problem, please write down in the comment box, and please like, share and subscribe my channel dear. Thank you.